In this chronicle of Intro to Programming, we're going to look at how we can add in interactivity using the mouse. And there's a lot of things we can do that would work with us on this, but what I'm thinking is we're going to do some type of game where we're able to move an object around with the mouse, and that's going to interact with other objects on screen. So I'm going to let the player become my mouse. So we will set up a player class, and then we will have our object class that we're working with. And a lot of the things that we're doing now should be viewed as normal, in that we don't need to go over all of it in super tight detail. And I almost made one of the most common typos on our typing the variable, and I used FLAOT instead of FLOAT. So I just want to point out that is a really common thing when your code breaks, that we know that that can be part of why. So now I just do my constructor, same way we've done everything. Always enter in your closing curly brace and then go back and put the contents inside it. That will help you mitigate the problems of where we forget to do that at times. And I'm just going to start it out in the middle of the screen. Y equals height divided by 2. And our width is going to be, we'll just give it 100. And we'll do 100. Now, you'll notice that that does make what I'm making actually circular, because I'm planning to do a round object, and that's okay. We could use just a radius for it, but we'll talk about that as our program progresses here. So we need to figure out our update method, and then we will have our display method. Now these are going to be similar to what we've used in the past. I'm going to just fill my artwork with red, and I will draw an ellipse. And the ellipse that I'll draw, I'll just draw it X, Y with height. So nothing too fancy there. We'll come back to this update method in a minute, but what I want to do is to go work a little bit on the rest of my program here. And this means we have an object of the class player. We'll populate that. P is equal to a new player. So again, making an object the same way that we've done in the past. And then we tell P to update and P to display. So shouldn't be anything too different here. We can see there it is. There's a red circle. The trick now is I want to make this go wherever the mouse is. And you'll be surprised at how simple this is. So we just say X is equal to the mouse X. That is the current X position of the mouse, and Y is equal to mouse Y. Now if I run it, I'll see that it started out the very first frame, it's in that top left corner, and then it goes to wherever my cursor is. So we can see as I move the cursor, this moves. And it's kind of fun. It's almost like I'm drawing a 3D snake, and that's cool, but I want to clear the background in between. So let's set that up, and we'll do void clear background. And I'm going to fill this with a light gray, if I can type, and I'll make it a little bit transparent. And then we'll draw a rectangle from 0 to 0, and then the full width. And the most common typo for the word width is we flip-flop the T and the H. And now when I run this, I made a method. But at the start of every frame, we should probably call it. And now we can see by using the slightly transparent filling instead of solid fill, we get this kind of little ghosting trail, which is just kind of fun as it moves around. It's just a visual effect. If you don't like it, just fill it with a solid color or set the alpha to 255. And when you do that, now we don't get the ghosting, but kind of like it. So I'm going to leave it. And our options are somewhere between 0 and 255 for how transparent we want that clear to be. That's our first start. Now what we need to do is we're going to add in some things. So I will say, now let's save this and see if that works here. Click New Tab. I'm just going to call it a thing. I don't know what it is yet because it kind of depends on what we decide we want our gameplay to be. And this is really where you get to customize it. And as you build your own code, you can figure out what you want it to be. Are we catching things? Are we pushing things? Are we making things respawn? Are we making them stop when we catch them? All these kinds of how the mouse will interact with something else will determine what we want this thing to be. So in the meantime, I'm just going to call it thing. In the interest of time, I'm just going to copy my player class. I'll paste it in. It underlines red because it's already been duplicate nested type player, I know. So let's change this to thing and change the constructor. Okay, so we've changed it. I'm going to make it a little bit bigger. We'll make it 200. Eventually we'll make it smaller because we're going to have a bunch of things, but right now I just want to get one thing happening on my screen here. And we'll give it a speed X and a speed Y. Need to give those values. Speed X, it's going to be equal to random. And we'll just give it a random value of -3 to 3. And speed Y, we'll have a random value of -3 to 3. I don't want to drop my thing into the middle of the screen. I want it to randomly appear somewhere. So we can choose random. And now with this, I can choose the values that I want. And I want it to be somewhere between 100 and with -100. And the height, same thing, except 100 and height -100. That now allows it to randomly appear somewhere on screen. X and Y are not going to be equal to mouse X. It will be plus equal speed X. And this will be plus equal speed Y. So we'll just say X is equal to X plus speed X, Y is equal to Y plus speed Y. That's what these statements do. So it now updates its position on screen. Go back over here. We have a player. I'll just do a thing T for now. We'll just start out with 1. And we update the player and update and display our thing. And we'll see, I want to set a random color for it. Let's run it again. See, it's now moving somewhere else. Okay, that's problematic. We need to make sure it stays on screen. So let's go into the thing here. And we're going to give it a property of C for color. And C is going to be equal to color random. So we have to set our red, green, and blue components. So that's my red will be 0 to 255. Our green will be 0 to 255. And our blue will be 0 to 255. So now we have random colors. And we don't fill it with red. We'll fill with that color C. There. Now let's run again and see, and it's a new color. Each time we run it, new color, new location. Wow, that's a really pathetic speed. But when we choose random values, that is indeed what can happen. So we have a thing, we have a player. But what we need to do to make this come alive is we need to figure out what happens when they're intersecting each other. And more importantly, how do we know when they're intersecting each other? That is the real question. So I've made a little sketch that has similar objects, but I made the thing fixed in its location. Then we have the player. And we can see that while their height and widths were 100 and 200, that means their radius, signified by this black line, is 50 and 100 respectively. So if I add those two together, that's 150. Now, what we can do in processing is we can calculate the distance between 2 points. And if I calculate the distance between the center of each circle, in this case it's 260, now we're under 200. As we get closer and closer to touching, you can see we're getting closer to 150, and then the moment our distance is less than the sum of their radii, we know that they're overlapping. So we're able to calculate based on the center of the object and what is the distance between those two center points and the sum of their radii. And when the distance is less than the sum of the radii, it's overlapping, and I've just made a yellow overlay occur so we can see that's happening. So that means we have intersection. So we're using simple math. We calculate the distance between 2 points, and processing has a distance function. We just plug in what is the center of the player, what is the center of the thing, and it gives me the distance. And we compare that to the sum of their radii. And that's how we know when our objects are indeed intersecting. So the question is, how do we write this? And the way that we can write this is back inside our main program here. Going to add another method, but this time it's not with void. I started typing void because the majority of functions we write all return nothing, so it's void. But this function is going to return a Boolean, a true or false value. So we're going to call this function and ask it to tell us when circles are intersecting. Later on we'll look at how can we do rectangle intersection. So when we have kind of rectangular shaped objects and know when those are intersecting each other. But the math is much simpler for doing it with circles, so that's why we're starting with that. So we do circle intersect, and we're going to call this method by we will send the player and whatever thing we want to know about to it. So we'll just call it player A, comma, and thing B. Curly brace, close curly, up arrow, so now we're into it. Now it's giving me a red underline because the problem is I said that this is returning something, but we haven't told the function to return a value yet, so that's why it's doing it. So what we want to do is we want to know if the distance between their centers is less than the sum of their radii. So if I'm just going to make two temporary variables just to try and keep things a little bit cleaner as we do it. So we'll do it, not temporary variables, but variables that exist only within this function. And so the sum of radii is going to be equal to, and we just go a dot width. Knowing my width and height are the same, so I could use h. We could have built our circles using the circle method, and it would only have a radius value anyway, but we take our width and divide it by 2. That's the radius of the player. And now the radius of my thing, which is now going to be b dot width divided by 2. Now I'll make a second one, and this time I'm going to say distance of centers is going to be equal to, and this is where it's super awesome. I can just call dist So I don't have to do any complex trigonometry between points and calculate anything. I just say distance a dot x comma a dot y comma b dot x comma b dot y. So we just pass in the 2 points, the x and y of a, the x and y of b, and that's it. Now I use a conditional. I say if dist of centers is less than sum of radii, at that point we want to return true, else, oh, we need a curly brace, closing curly, else return false. In Command or Control T to auto format, that cleans up our indents. We know everything is lined up. When we're coding, we always want to make sure that our curly braces do have a partner. So I click by this one, it highlights that one. So the opening, closing one for the method here, this goes to there, this goes to there as part of my if. So if my distance centers is less than the sum of the radii, it gives me a true value, otherwise it gives me a false value. So you're probably going, okay, that's great, but how do I use that? What do I do? And here is the magic trick. And what we can do is just simply say if circle intersect, and we have to say who we passed in. We passed in a player and a thing is equal to true. So when we're asking a question, we use double equal signs. If we're comparing something, we use, or setting something, we use a single equal. So anytime we're doing a comparison, we're saying if this statement is fact, that they are intersecting. What I want to do, I'm just going to do, I'll do the yellow, well, we'll do a green overlay this time, just so for something different. So fill 0, 255, 0, comma 100, and then we'll draw a rectangle. This rectangle will draw the full width of the size. So and when we do that, we can run it, and we can see when we overlap. But we probably do need to take care of something on our thing here, and that we need to adjust its boundaries. I'm going to close that one. We don't need that anymore. That's distracting me as we have it up there. But what we want to do is we want to work on thing so that thing has a way to check its boundaries and it can stay on screen. So void check bounds. And when we're checking our bounds here, we'll just have a couple if statements, one for each margin. So if my x is less than negative width of the object, then that means my x is going to be equal to the width. And on ones like this, we can put it just on a single line when we're typing. If we auto format it, we'll put it onto multiple lines. But when I'm doing simple ones like this, I enjoy just putting it on a single, oh, forgot my semicolon, and then close my curly. And remembering back, it was prophetic that I said that's the most common misspelling for width because I just misspelled width that way. So if y is now less than negative y, meaning I've gone off the top, then what I want to do is set y equal to the height. And my punctuation is failing miserably today. So hopefully, you get the gist of it even when I am having some issues. So we could put in both of them and now go y. Y is now equal to, so if we go off the height, then we want to go back. Okay. Now, under our update, spell check bounds. Let's run this again and see So we'll see it should. And we got a weird because we went off one margin than the other, so we're getting some kind of odd things. When our object is this big, it's a little bit harder to tell when we're getting that weird overlap, but it is indeed working, and it seems it's gone off all four margins now. It should show up down there and there. Okay. So with the size of it, it's a little problematic here. I'm going to shrink this down to a much more kind of, when we have a lot of objects on screen, we probably don't want it really big. So now we have little guy here. We might even want to, okay. And looking in here, I can see, oh, y, negative y, whoops. That should be an H there. So I think that might be part of what just broke it right there. So it's always good to check your code when it misbehaves or does weird things. So now we can see it's indeed pulling itself and moving. Now there are times when you work at that, what we do is we go more than just right at the edge and immediately wrap to the next edge. We let things go even further off screen. That can make it a little bit easier. Now one thing we'll notice is sometimes, especially at the bottom, we get that weird glitch where it's half on, half off. And well, our intersection is working correctly. Our boundaries of border checking are based more on using a rectangular object, and that's because by default ellipses draw from the center where rectangular objects draw from their edges. So that's why when it goes off screen you sometimes get some odd artifacts happening with that. And we can see the difference. If I go under display and just draw a rectangle here, and we'll just draw it XY with height, and let's watch what happens. When we do that, we can see that rectangle is drawing from that center of the ellipse. So the rectangle will behave exactly correct on our border wrapping, but our ellipse is not because it's drawing from the center. Now, if that's truly problematic and going to break your game, you can calculate how we need to change check bounds, and I would challenge you to do that. Ultimately, I'm not going to worry too much about it because the logic we have here is going to serve us better as we move into rectangular objects, which is something that happens when we start using images. So we move into images, we always draw them then from the top left corner. So I'm going to be more concerned about that. And when we switch over to using rectangular objects for intersection checking and things like that, it's just going to be easier. So if you're wanting to fix it, you need to modify your check bounds values a little bit for this one. If you don't really care, because it's not going to break your game, don't worry about it. The question is, how do we set it up so that we can catch our objects and do something with it? We want to affect our objects and have something happen when they intersect each other. And that's kind of the question of what do we do with that. So when the player hits a thing, we could do, that effectively that object has been caught. So what I'm going to do is I'm going to make a new method inside my thing class. And I'll call that method caught. Now what I want to do within this is I just want to make this, well, just say our speed x is now equal to 0 and our speed y is now equal to 0. So instead of, well, we can leave that there if we want when we intersect, but what we really want to say is t dot caught. Now if we run this, let's see what happens. It's there, and we can see now we killed its speed. So that's one thing we could do, is we could kill its speed. Another is we could position it off screen so we no longer see it. So it looks like it disappears. That, you know, it's gone. If we want to turn this into a full-featured game, we have to start thinking about, well, what else could we do? How could we work with it? I mean, very realistically, we need to have lots of things, not a single thing. So what I want to do is to set this up so that we have multiple things here. So we'll say thing, square brackets, things, and every time I add in my array version of it, I'm just going to comment out what I had previously. Every time I add in the array item, I'll comment out the singular. So things is equal to, and this is going to be an array. Oh, sorry, things, thing, and we'll just start out with 10 things. Oh, duh, I forgot. I'm like, it's red. There we go, new. So we're making a new array. We'll put in 10 things into it. Now we use our for loop to do this. Oh, let's comment out this one here, because we keep commenting about for int I equals 0. I is less than things dot length. I plus plus, curly braces. Inside there we go, things, square bracket I, so we're going to add to each item in the array is equal to a new thing. So that now gives me my 10 things. Now, we don't just tell each thing to update and display and check out if it's been caught. We're going to do that inside a loop here to go through all of our array objects, remembering our lessons from before. So the standard for loop that we're using for iterating over an array of objects. This time I'm not going to comment these out. I'm just going to cut them and we'll paste them in here and then change t to things, square bracket I, just like that. If you want to use copy pasting to do it, and then auto formatting to clean it up so we know that all of our things. So we should end up with the 3 curly braces at the bottom. So that goes with our intersect, this goes with our loop, this goes with our draw method. So now we have 10 things and we can try and catch all 10 things. Let's give this a go and see how it works, and as I catch each one we see they stop moving. Now if we don't want to stop them under caught, if we want to make them just disappear, well, we could kill their speed, but we can also just go x is equal to -1000, so we know that guarantees it's off screen, provided our artwork's not 1000 in size, because then that'd be problematic. But now every time I catch one, it just, we get a little hint of a flash of green. So we can see as we catch them, they're dropping over to the side, and that's because our check bounds is, even though we said go to -1000, it's limiting. So that means we've gone way off screen, so it now puts it on the other side, but their speeds are 0. I'm not going to worry too much about it right now, because eventually we're going to have a little more complex state system built into this, and as we do that, that's going to minimize what is happening with it. So one thing that we could do is we could certainly just put them somewhere else after we catch it. It now spawns at the edge of the screen somewhere and then starts navigating its way in with the new x and y and speed value, effectively resetting it. So they're always just spawning and reappearing, so you're continually trying to capture. Now, if all your drops are, say, only working in one direction, so let's say we have speed values so that the speed x is going to be 0, and our speed y, let's just say, is 5, like this. Now what we'll see is all the drops are falling. Now when I catch a drop, it dumps itself over there. But if all the drops are going in the same direction, once this happens, instead of killing their speed, what we can do with 5 drops is we potentially could have something like a reset method. Now it scolded me and turned red because we didn't have a reset method yet, so we'll go and make that. Now that's not red anymore. And what I want with the reset method is I want to have a random x and then we'll reset the speed. And maybe I go for a random speed at some point, who knows. Now when we catch it, so we have 5 drops, and oh, forget to reset their y value. I want my y here. I knew there's something I was forgetting. So for only having 5 drops, I can now play or 10 drops. I can play this forever as I'm always getting 10. Now we probably don't want them all to have the same speed, but I mean you'd swear that there's a lot more drops involved here. So we're recycling our assets, and that's really where some of the magic happens, is we're recycling what we're doing. So we can move things all in random things. We can have it go in single directions. Maybe we start out where it's going to be a fixed speed for everything, and then we have a random value, and maybe I go somewhere between 3 and 7 on it, so that every time they reset they might be going a little bit, some are faster, some could be going slower, and it further creates this illusion that they are random. I want to really make them seem new each time. I should also give them a new color when I, well, so they will become a new color. I hit the wrong, I highlighted and pasted it, or recopied the empty line, so I had to go back and repeat it, in case you're wondering. That's weird, but now every time I catch it, so you really have no idea that as I'm playing this, that there's only 10 of these items falling. And we can start to see that trail effect is kind of fun here on it, because now they get that little bit of motion trail happening as they move with our translucent background occurring. And I'm trying to sweep them up, and it seems, it's near impossible to do so. So the challenge is going to be think about how can we gamify this? How can I turn this into something where we have a way to win, a way to achieve, a way to lose, a way for it to start and stop? How do we go about doing that? How do we store that information and turn it from just a simple proof of concept into an engaging, fun game experience? And that will be our next challenge.